All right, so I think I'm recording. Let's take a look at this problem number 6. We're looking at our review problems from Skill Packet 7, and problems 1 through 6 are really basically the same idea of coterminal angles. And problems 2 through 6, and problems 2 and 3, they gave us angle measures in degrees, and we worked in degrees, and we added or subtracted complete revolutions, and a complete revolution in degree measure is 360 degrees. So we created this list of numbers that were all coterminal angles with respect to each other. If you draw them in standard position, they all have the same initial side and same terminal side. Well, with 4, 5, and 6, we're doing the same idea, only we're working in radians. And you're a little bit less familiar probably with radian measure than you are 360. With a radian measure, one complete revolution is 2 pi radians. And when I add or subtract complete revolutions of 2 pi, I often have to rewrite 2 pi with a specific denominator in mind. I think we wrote them with, let's look and see, with a denominator of 2 and with a denominator of 3. But here in this problem, I don't have a denominator, I just have a decimal number. So if you'll notice in the last problems, I started out by drawing the angle in standard position. And here, 4.375, you may not be familiar with, well, what quadrant is that angle going to lie in? So what I need to do is get decimal approximations for pi over 2 radians, for pi radians, for 3 pi over 2, and I suspect that this 4 pi over 3, well, I know that it's going to be less than 1 revolution than 2 pi, because pi is about 3.14, and if I double that, 6.28, this 4.375 is less than that. So on this next slide, that's what I did, is I just wrote my decimal approximations so that I can see that this 4.375 is bigger than pi, but smaller than 3 pi over 2. So when I draw in standard position, I know I'm in quadrant 3, and that this angle, since it's positive, has a counterclockwise rotation of 4.375. Good morning. Mrs. Johnson just poked her head in here. We've been sharing classrooms and stuff, and she's in here during the prep, and she had to come in here this morning. All right, so let's get back on track here, or I should get back on track. For you, it didn't seem like any break at all. I had 4.375, and I didn't know which quadrant to place it in, so I knew that pi over 2, pi, 3 pi over 2, and 2 pi break up my my boundaries for my quadrants. And when I get decimal approximations using 3.14 basically for pi, I get that pi over 2 is 1.571 and so forth. And I see that 4.375 is bigger than pi and yet smaller than 3 pi over 2, so I know I'm in quadrant 3. So now I've drawn my angle in standard position, and I'm going to add complete revolutions, which means I'm going to add, 2 pi to each one, and I'm just going to approximate 2 pi as 6. Well, I guess I really don't need to. Here, I'll show you what I do on the calculator. If I add 2 pi, I just come over and set my calculator to whatever place that I want to rotate. What am I trying to say? Round it to 3 decimals, and if I take 4.375 and if I add a complete revolution, it did not round it. I must not have hit enter. Okay, so 10.658, and then if I add another 2 pi to that, this is supposed to be theta 1, and this is theta 2. So here's two angles to where all three of these angles are coterminal with respect to one another. Now I want a couple of negative angle measures. So let's subtract 2 pi. Let's let the calculator do the work. Never have a problem with that. Negative 1.908. Then subtract another 2 pi. And I'm getting negative 8.191. So all 5 of these angle measures, the one given and the 4 that I have found, are all coterminal because we've got them all by starting with one of them. It doesn't matter which one we start with, and add or subtract complete revolutions to generate the others. So I hope that helps, and I will talk to you later.